Welcome to another glorious session of video notes for our unit. What we're looking at today is how we solve absolute value functions so that we can actually say, given all this stuff, what would x equal? Just like before, I encourage you to pause if you need to be able to catch up and continue on, then start it whenever you're ready. So when we're looking at solving absolute value functions, we have 5 steps that we're going to follow for this. Our first step is to isolate. And when we are isolating or getting alone the absolute value. Okay, so whatever is inside of those absolute value bars, right? You'll have x inside there. You may have plus or minus things, whatever is inside of those absolute value bars, you need to get that all alone on one side of your equal sign. Okay. The second thing that you do is you do a check for no solutions. Okay. We said before that absolute value what that means is distance from 0. You cannot have a negative distance. So if your absolute value equals a negative number, say, I don't know, 3, like whatever, if it equals a negative number, then there are no solutions because you can't be negative if you're taking the absolute value. Okay. So after we've isolated and we check to see that what we equal is a non-negative number, we will write 2 equations. We'll call them 2 OR equations. One that is positive and one that is negative. I'll explain what I mean by that when we're looking at our examples. Now that you have 2 equations, a positive equation and a negative equation, you solve each equation independently. Okay, so you solve each one of those. And then your last thing that you do is we check. Okay, we do a check for extraneous solutions. And in our last example, I'll explain what I mean by that and how we go about doing that and what an extraneous solution is. Okay, so these 5 steps here are the steps that we will follow for solving all of our absolute value functions. So the first one we're going to look at, we have the absolute value of 3x plus 5 equals 14. So the first thing that we have is we need to isolate the absolute value. So everything that is within these bars, those absolute value bars, we're treating as one unit. Nothing goes into those bars, nothing comes out of those. That is what we want to get alone. So what I have over here that doesn't need to be with it is that plus 5. So I'm going to subtract 5 from both sides to now have the absolute value of 3x equals 9. Okay, so now those absolute value bars, they are isolated and I can move on. I check, I have my absolute value, it equals, well, it doesn't equal a negative number, so I can carry on. I write my two OR equations, one that is positive. When I do this, I am taking whatever was inside of that absolute value bars. Now the bars come off. Like they were there, imagine they slide off, and now I make one equation that has what was in there equaling the positive of what was on the outside, and the other one, or what was inside that absolute value bars equaling the negative of whatever it equaled. So now I solve each of these independently. So here, this one I divide both sides by 3, and I get x equals 3. Or when I solve this one, I divide both sides by 3, and I get x equals negative 3. The reason I have to use or, if I use and, I mean simultaneously. So if I said x equals 3 and x equals negative 3, what I'm saying is I want x to be 3 and negative 3 at the same time, which isn't possible. You can't be two numbers at once. You either are the number or you are not the number. So when I use or, I'm saying it can be 3 or it could be negative 3. That I'm allowed to be simultaneously. And here is the solution there, okay? I know you're saying, what about step 5? I will talk to you about step 5 when it is pertinent. Okay, our next one. We take what is in this absolute value bars. That is what I need to isolate. This 2 is currently multiplying. Again, you cannot take anything out of the absolute value bars, nor can you put anything in. Do not distribute into the absolute value. What you do here, I divide both sides by 2. So now I have the absolute value of x minus 9 equals 13. Now that absolute value has been isolated. It is all alone. So now I can take those bars off and write my two equations. One that is positive, taking exactly what is in there, x minus 9 equals exactly what is out there, 13. Or the negative equation, where I do x minus 9 equals the negative of whatever was on the other side of the equal sign. So equals negative 13. I'm going to move this just slightly in. That way it's not on that line. And now I solve each of these independently. For this one, I add 9 to both sides. And I get x equals 22. Or when I look at the other side, I add 9 here to both sides, and I get x equals, what's that? Negative 4. Okay. You do not always get one that is the positive and the negative of the same number. As we see here, 22 and negative 4, they are not the same number. So those are my solutions. X can be 22 or X can be negative 4. Now I want to make a distinction here. When I say check for no solutions, absolute value cannot equal a negative number. X, what I solve for, X can equal a negative number. And so that is fine to have. Okay, our next one. Next example that we're going to look at, we have -3, absolute value of x minus 7, plus 8. So I need to subtract 8 from both sides. I've got -3, absolute value of x minus 7 equals 6. I then divide both sides by -3. So I get the absolute value of x minus 7 equals -2. Absolute value cannot equal a negative number, okay? It doesn't matter what number I put in for x in this right here. When I take the absolute value, I take and make it not negative. So here, if it equals a negative number, well, that's not possible. Here we have no solution. Okay, that is what this step 2 is, where we check for no solutions. If I've got one side isolated, absolute value, and it equals a negative number, there is no solution to that. Now, example 4, we have something different here. Because I have x both inside of that absolute value as well as outside of the absolute value. It is in this situation that we must do step 5, where we check, and we'll get there on this. So it is isolated, and at this point, because I don't know what x is, I really can't do the checking for no solutions. So I just carry on writing my 2 equations. One that is positive, where I take exactly what is in these absolute value bars, and it equals the positive version of what I have over here, 3x plus 4. Or when I do my negative version, it is still what was inside the absolute value bar, x minus 8, equals, and I'm going to multiply what it equal to by -1. So -1 times 3x plus 4. And now I solve each of these independently. So on this side, I'm going to move all my x's to one side, all non-x's to the other side. So I subtract 3x from both sides, and I'm going to add 8 to both sides. So when I subtract 3x from both sides, I have -2x equals 12. And I divide both by -2. And I get x equals -6. So that is one of my possible answers. Or I have the other one that I could be looking at as well. For this, I need to distribute that negative to both the 3x as well as the 4. So I have x minus 8 equals -3x minus 4. I now add 3x to both sides and add 8 to both sides. So that I'm moving all my x's to one side, non-x's to the other. And I've got 4x equals 4, because -4 plus 8 gives me 4. So I divide both of those by 4, and I end with x equals 1. This step 5 of checking for extraneous solutions. This must be done when x is inside and outside of the absolute value. Okay, so when it's both inside, when I have an x in the absolute value, as well as on the other side, I have to do this. An extraneous solution. Extraneous solution is a solution that you get algebraically but when you were to use it, it doesn't work. Okay, so it's a solution that you get from doing your algebra steps. However, when you go back and check it, it doesn't fit the criteria to make that a true statement. Okay, it's fake. It's a fake solution. So to check this, you just take it and plug it back in for x in your isolated equation. So I have here, I have the absolute value of -6 minus 8 equals 3 times -6 plus 4. Okay, so inside here, I've got the absolute value of -14 equals -18 plus 4. The absolute value of -14 is +14 equals -18 plus 4 is -14. +14 is not the same thing as -14. This doesn't work. Okay, that one doesn't work. This is an extraneous solution. Okay, we got it algebraically, but when we tried it back in, it didn't work. When I try the other one of x equals 1, so I've got the absolute value of 1 minus 8 equals 3 times 1 plus 4. 1 minus 8 is -7, so the absolute value of -7 equals 3 times 1 is 3 plus 4. Absolute value of -7, when I evaluate the absolute value, that is just taking it and making it positive, equals 3 plus 4 is 7. That is true, that works. So the only solution I actually have here is when x equals 1. So even though working it algebraically, I got 2 solutions, one of those solutions was extraneous, didn't work for the situation. And so it isn't an actual solution. So I'm left with just x equals 1 as my only solution. Should the case have been that both x equals -6 and also the case of x equaling 1 were extraneous, then in that situation, you would have no solution. I want to make sure it is clear to you. It is not because x equaled a negative number that it was no solution. It's because when I put that value back in, it gave me a false statement. Up here, I have an x value of -4. That is okay. X can be negative. It's just absolute value cannot be negative. So these are the notes for today. Mainly it is these 5 steps that we're looking at to isolate the absolute value, get what's in those absolute value bars all alone. Once it is isolated, checking to see if there are no solutions because it equals a negative number. Then our third step, writing 2 OR equations. One that is positive, where I take what was in that absolute value bars and it equals what it equaled. The other one that's negative, whatever was in those absolute value bars equaling the negative version of whatever it equaled. Then we solve each of those independently to arrive at the 2 possible answers and check your answer. You must do that when you have x's inside and outside of the absolute value. Please ask questions of us in class. That way you can better understand and do well as you're doing this. Have a good one.